The theme of this panel is Evidence-Based CSS, Insights from Academia. We are honored to have the following panelists with us today. Professor David Chan, Lee Kong Chiang Professor of Psychology, Director of Behavioral Science Initiative, Singapore Management University. Professor Jeroen van der Meijde, Assistant Professor, School of Architecture, the Chinese University of Hong Kong. Professor Zheng Han Kang, Professor of Sociology, Yonsei University. Professor C.Y. Chiu will be the host of this session. Professor Chiu is George Ming Lee Professor of Psychology, Dean of Social Science, the Chinese University of Hong Kong. The discussion will be followed by a Q&A session. Online participants could submit their questions to the Q&A box. For those who are here, you can simply raise your hand and our staff will pass a microphone to you. I will now pass the floor to Professor Chiu.
Thank you very much, Angela. On behalf of the Faculty of Social Science, the Chinese University of Hong Kong, a cool welcome to our campus. I say cool because I think the outside temperature is high, and I think we are all very cool here. So cool welcome again. And today I'm really happy and honored to be among the experts in social and behavioral science who would share with us their insights on both the upsides, the promises of computational social science, as well as the emerging concerns about computational social science in our society. So I want to start with a question to David. Okay, so David, I know you are a very eminent behavioral scientist, and I also appreciate very much your insights on how behavioral science can contribute to the well-being of individuals and the society. Now, today we have heard the term computational social science many times. What exactly is computational social science, and why do social and behavioral scientists care about this? So can you also give us some example of how the application of computational social science can enhance our understanding of subjective well-being, knowing that you're a champion of subjective well-being research as well as application around the world? David?
Okay, can you hear me? Okay, first, thank you, CY. CY is a long-time friend, so you might see the friendliness among us when we were doing the multiple photo taking. First, thank you very much for coming here, the live audience, and of course also our friends, colleagues, and audience all over the world tuning in now, and I guess also tuning in after when the video is up somewhere, for several weeks and months, hopefully. Thanks also to CY for the general question. It's broad, multifaceted, and general, so allow me to say anything without going wrong. And I guess the first question we want to ask ourselves, and I'll keep it general, right, so that we can have more discussion later. And this is not an academic workshop, so probably better to just cover the general issues and then to maybe stimulate our thoughts and thinking. And I would say feelings also about computational social science or sciences. I guess the first question to ask ourselves is it CSS, is it computational social science or computational social sciences? Right, and don't worry, people who did the format computational social science. Now, in the past, when I first come across this term, I was very upset when it says computational social science. I said it should be sciences, right? Because obviously it belongs to no particular one discipline, not computational science alone, neither social science alone. In fact, social science is, if you say social science, the schools get mad because it's social sciences, right? There are so many disciplines, psychology, philosophy, sociology, and then some people will say humanities is also part of social sciences, depending how you look at it. So I was quite upset for a while about computational social science, the word without the S, several years ago. And it was only quite recently, I would say, a few years ago still, because I'm quite old, a few years ago, and I began to realize that actually it is correct, both sciences and science. Sciences is important because it actually highlights to us that no one discipline has monopoly. right, over the insights, over the science, over the applications, and so on. And by using the word sciences, I think it allows all of us, and a combinatory works like this works best. It's like cognitive science in Stanford when it first came out. It works best when you get the best people from all the individual disciplines, not the leftovers who have nothing to do. Then let's come together and do some interdisciplinary work together. So when you get the best people to come together to do computational stuff and also social science, actually there is a challenge, because everybody who is an expert or the best people in your own discipline, actually including myself, right, we tend to think that, oh, we are right. So there is a lacking of humility sometimes in our own paradigms, and say, there are some parts of your assumptions in your paradigm that are actually not very correct, or maybe even misleading, right, in addressing this practical problem that we face as individuals and society. I think it's in that spirit that the word sciences is very important to be emphasized, that we all need to come together as different disciplines, because the world is not compartmentalized into the disciplines that we organize in universities. But the word science singular, I think, is also correct, right? Because it is not just multidisciplinary. As the theme goes, it's transdisciplinary. It goes beyond discipline, because discipline is just about organizing knowledge. I think when you look at the word science, then it begins to emphasize a unity among us, and that is that the belief in evidence. The belief in hypothesis testing, the belief in that it is not just CY's opinion or mine, but the belief that when we come together, there is a way to resolve disagreements, and that is to look at what the evidence has to offer. And hence, we have the ideal of evidence-based insights. The insights that come out of CY, myself, and my colleagues is not just our opinion, our background, and so on, but it comes from evidence. So when we look at that, evidence-based insights, then we will have the humility to agree that, yeah, David, it's okay that you were wrong yesterday, today, because in the light of new information and new data, I am okay to now change my view. Then policymakers have to do the same, because then it will not be seen as a U-turn, but to see as the humility, the adaptability, the ability to understand that in the light of new information, one needs to change. Right, so I think it is with that, I will just sort of round off my first general comment, right? And that is that it is both sciences and science, because there must be a unity when we come together to try to go beyond our own discipline to understand, say, as a scientific enterprise, right, in terms of creating, applying, and disseminating knowledge, how do we solve and address practical issues? What are some of these practical issues? I think it's quite clear. Our guest of honor and our two university presidents, in fact, have done the job for us, right? It's highlighting to us that the world is really quite challenging, right? There are complex changes, which of course raises the issues of adaptability and well-being. And so, when you look at computational social sciences, what we really have done is that the disciplines have tried to address practical issues, right, in domains such as retail, logistics, urban planning, addressing issues such as education, health, community development. And these are all about using evidence-based insights in order to solve practical problems. Now, if we scientists realize that it is really a problem-driven enterprise which brings us together, I think we will have the humility, and we will have the impetus and inspiration to really come together and to give our best, realizing the strengths and limitations of each discipline and each individual. And then we can really truly say, oh, we are not just multidisciplinary, but you can be transdisciplinary, where first off that the paradigm clashes will occur definitely, especially between computational people and social science people who might share quite different paradigms. And I'll just round off again, I think on adaptability and well-being during question and answers, we could always address those issues. But I will just round off by saying that in the past 30 years ago, in fact today, if you go and Google the word computational social science, the definition is very misleading. Right? It will tell you that, oh, it is using of simulations and model to analyze social phenomena. Right? That you will get that as the most Googled definition. That was true 30, 40 years ago, right? When we started to say, hey, maybe computational agent-based modeling can tell us something. Today is quite different. Today, what you and I are doing in computational social sciences is simply different collaborative research where disciplines come together to address issues that matter at different levels of analysis, including individuals, group, and society, using the knowledge and evidence we can get from all disciplines. And that would, of course, include your computational technology, your big data analytics, your statistics, your social sciences like psychology, sociology, management, and so on. Right? And once we understand that, then I think it makes life much easier. It makes communication possible. You, of course, need platforms like this where you bring people together to talk, right? And on that no, I think I have talked too much. I think it is time to hand back to CY, and then we can always engage again in further discussions on this.
Thank you, David. I remember that when I first took up my job as Dean of Social Science in singular, people ask me this question, why is the Faculty of Social Science named as the Faculty of Social Science and not the Faculty of Social Sciences? So I think I gave an answer to that query a long time ago. In the interest of time, I won't bother you with my answer, but I think David actually gave a very good interpretation of what social sciences and social science could mean, particularly for the future development of computational social science. Now, David have also alert us to one very important aspect of computational social science. Social science used to be very theory-driven. And I still remember that at the time when I did my PhD, my mentor told me that today, if you have a copy of Microsoft Paint, which is a software for drawing flowchart, you can have your own theory. So everybody have their theory, and everybody have many theories. Okay, so that is the kind of theoretical pluralism. Perhaps it's good, but at the same time, okay, what I see is exciting about computational social science is that it pushes us to also think along another dimension, and that is how do theories help us come up with better solutions to solving complex problems. And I think that is exactly what David just told us. How could we, aside from having a theory-driven, theory-oriented social science, could also develop a solution-oriented social science, which is made possible with the advancement of computational methods. And with that, I would like to ask Yuan this question, okay, which I think is also very challenging. As David said, okay, computational social science make a lot of promises. Now with access to more nuanced data, more accurate data, more accessible data, presumably we should be able to leverage on the data and make better design, say for example, for a smart city. And I know that you have been doing a lot of work in this area. Can you share with us some of your insights about what computational social science could actually deliver to people in your profession, in your discipline, for the betterment of collective well-being?
Thank you so much. It's a very challenging question indeed. Maybe just first to introduce also where I'm coming from in relation to your question about multidisciplinary and transdisciplinary. I'm working in the School of Architecture, which is in the Faculty of Social Sciences, very unique and beneficial situation here in Hong Kong. Teaching urban design and working on urban design projects, which also overlap a lot with geography and meeting many colleagues also the last few days, overlaps a lot with sociology. Our work is already multidisciplinary and very much sort of human-centric. Our own working title for our research is Data-Driven Urban Design, which is in a way also a much wider field. The first applications in that have been already around since a long time around, for instance, transport planning or environmental design, especially in CUHK, which is a very good examples of where data and very precise modeling can make real benefits and solutions and improvements, for instance, when it comes to urban microclimate, better temperature control and pollution dispersion for housing estates, etc. But those may be still more like a hard scientific endeavors, where I think my work, where it overlaps more with computational social sciences, that we're interested in health and well-being. Even though those other projects obviously also overlap very much with that field. So my team, we're working, for instance, on Google Street View image analysis, which a lot of people are doing anyway, but we're looking in Hong Kong, for instance, to analyze the amount of street greening, street frontage, the liveliness of street frontage, and also to actually detect the densities of people we can see in the Google Street View images to understand the relationship between aspects of the urban environment and liveliness or vibrancy of certain neighborhoods or streets within neighborhoods. So the data helps us to get a much more fine-grained picture of how well different urban environments are actually supporting a kind of a mixed use and providing a range of facilities for, especially for vulnerable groups. And then also using large-scale data scraping, social media data, to understand much finer patterns of activities and movements of people in those neighborhoods. So it really helps to understand across urban districts where the sort of underserved areas are, and also where the people are living who need maybe more service and good access to facilities. So using spatial modeling, we can understand, for instance, how elderly people who are trying to do aging in place can have good walking connections to healthy food or recreational facilities, which help them maintain a more active lifestyle, and also to judge the quality of these walking connections and spaces that people are moving through. It's still sort of early stages, so I won't claim that we have already contributed to data-driven design, but we're trying to develop the methods and tools for that at the moment.
Thank you very much. I want to follow up on your question, your answer. One of my experience as a lay person in contact with computational social science is that it completely changed my understanding of computational and social science. So when the word computational pop up in my mind, okay, I see a lot of numbers, zeros and ones in front of my eyes, right? That's my mental image. But one experience I have with computational social science papers and reports that I read from my colleagues is that, well, actually, computational methods allow me as a user to have better feelings about the reality, better vision of the reality. I can feel the temperature changes from area to another area with all those wonderful visualization tools. I can go beyond the immediate environment and start to imagine, say for example, what the environment would be like if I change a certain parameter here and there. Okay, could we turn this room into a desert if we change a certain parameter? I can actually feel it, I can see it, I can hear it. I can imagine how things work. And now I think you are a very well-known architect in Hong Kong and in your discipline. So can you give us a few examples of how those tools actually transform the way we relate to the reality, we relate to our space, we relate to other people, and we even relate to time? Okay.
Thank you. Yeah, it's the key challenge now is to try to quantify qualities, right? And especially when those qualities have this kind of ripple-on effect. So we may, for instance, know that just a few degrees lower in an urban space in between public housing towers actually prevents elderly from developing heat stroke and therefore makes them more comfortable to come out. And then there's a lot of follow-on benefits and advantages from that people are more likely to come out to share the same space and time together, which may contribute to, over time, a feeling of connection, a sense of belonging, the community forming, which is so important for aging in place to, enable the idea of caring in and by the community, right? That you can just rely on neighbors for help rather than the healthcare system. So it is a bit indirect, but the key through many academic studies is to find those very specific parameters and variables like that 2-degree difference. That it's not my work, but colleagues are working on that. Or in my case, for instance, the width of a sidewalk, or the relationship of how many street frontage and active retail will liven up a public space to attract more people to stay there rather than just passing through. And that sort of distinction between the use of public space just for functional criteria to just get as efficiently as possible to work, but on the other hand, if public spaces can actually invite people to slow down and stop, and actually maybe interact with strangers, so that the city becomes a nicer place. And it's in a lot of small details that are quantifiable.
Yes, well, and those quantifiable details are properly major contributions of computational social science. And I can actually see the connection between what you said and what David have said. So like in engineering and in architecture, we have focused very much on the efficiency, how design can enhance efficiency. But now with the introduction of computational social science, we add the social dimension to the formula, we add human dimension to the formula. And so when we design something not only for the purpose of enhancing efficiency or even sustainability, but also to make a city, as I think you mentioned to me once, more livable. More livable for human beings. We can build into like subjective well-being as one of the design goals, and then by putting in a computational social science perspective, we can actually see, okay, how changing the environment can actually impact subjective well-being, and that is more doable through this transdisciplinary and multidisciplinary approaches with very powerful ways to visualize and to feel the data. So I think that is exciting. Now, that is, I think, the upside and also the promises of computational social science that actually create more challenges for us, because we are now taking on more challenging problem and trying to offer better solution. Now, but there are also raising emerging concerns in computational social science. And so I'd like to ask John Hand this question. I mean, I noticed that in 2016, Oxford Dictionary have chosen post-truth as the word of the year, making the argument that digital transformation of society is going to make people rely more on their intuition, on their instincts, on their emotions in making decisions, rather than relying on their reason. So that is actually quite a big irony, right? So presumably the availability of nuanced data, accessible data, should afford more rational decision making. But at the same time, we're also entering a post-truth world when people tend to make decisions based on emotions and instincts. Okay, so the question I have for you is this really happening? And if this is really happening, is this inevitable or inevitable? What can we do as a behavior and social scientists to address this paradox?
Okay. Thank you for inviting me as the first South Korean partner to this global forum. And I think there is a reason why you invite sociologists. I mean, sociologists are pretty good at revealing the dark side of anything, and they don't really much help to find solution. But I mean, I will do my best to find a solution how to solve this post-truth society. I think that Irun already explained a lot why these global cities are important in the age of digital data. And the point is that I think if our data are not analyzed, that you cannot be served. I mean, so, and the data are accumulating on bigger global cities. So that's good. But the problem is we are not just analyzed, but we are over-analyzed. So all those forms and algorithms kind of divide us into very tiny digital tribes. So we live in our own truth and evidence. So our mission is, can I build a common evidence, scientific evidence, which can go overarch these different tribes? I think it really matters, and it's a serious social problem because the key problem of this digitalized data is if we have more data, we also have more outliers and noises. So if you just collect noises and make up a good story and advertise it, then probably some digital tribes will be convinced by your story. So I would call it a very biased narratives. So I mean, solving this problem is very important because it's kind of very unstable balance between evidence-based civic system and post-truth civil life. So it's a good combination, and we need to solve it. So how can you solve it? So I guess we need to develop more scientific, I will call it scientific narrative mining. So think about who really make up those very biased narrative based on outliers or noises. Then you may think of some extremist politicians or YouTubers, or there's social media influencers. But these days, we have generative AI like ChatGPT. So if you put those outliers into ChatGPT and ask it to make sense of those outliers, it will generate narrative. So I mean, the things are more serious that generative AI generates narrative. So we need to build more scientific narrative mining, which can counterforce that kind of aimless generation. That's a potential risk, I think. So how can you do that? So I believe that scientific evidence is not equal to data. So it actually reflects the scientist's perspective or paradigm. So in the same sense, if here's a social media data or whatever, some passive digitalized data, then it cannot be reduced to the data mining or statistical patterns. It has those narratives of social actors who really generate this data. And I believe we have computational tools to mine those narratives scientifically. Natural language process is actually pretty well developed and still developing. So for example, I don't want to get into details, but those kind of semantic role labeling is an effective way to extract the basic unit of narrative from the text or image data. And South Korea is not in good position because we use Korean language, and Korean language doesn't have good semantic role labeling, but English or China, they have much better role labeling, I believe. And we have those network science and some clustering algorithms to combine and show the entire structure of narratives. And as a social scientist, we have those intuitions and insights which can really decompose the entire narrative structure into sub-components depending on the social context and so on. So I think that's the way we have to proceed. So the point is that the evidence should include both statistical patterns and narratives. Otherwise, I mean, human beings are not really persuaded by patterns only. I mean, it's not empathetic. We are eventually persuaded by some storytelling, which we put ourselves into it and feel kind of empathy to that. So I think that's a social scientist, a way to solve this or contribute to this post-truth society.
Thank you very much. I find your proposal of using the narrative mining as a way to at least like identify possible biases, narratives is very powerful and enlightening. Now, but I have a follow-up question on this. I mean, now, as you mentioned, ChatGPT is also capable of using natural language to produce narratives. And it may become increasingly difficult to really like distinguish what the ownership of certain narrative on the internet. So the information in the internet will certainly be used as input into the database of all these like generative AI platforms or tools. So, and also communication is very interactive. Okay, it's not just like the data there, and then we extract the data, we analyze the data. The act of analyzing or retrieving the data is also a process of creating data or new data. So that seems to me a super complicated process. I wonder whether we are actually capable of doing this, or do we need to develop another generation of AI to do this for us?
Yeah, that's really a challenging question. And I don't know. I'm not a computer scientist, and I don't know much about this ChatGPT generative AI. But what I know is that there's this encoder and decoder for that transformer machine learning. But the ChatGPT doesn't use any encoder part, but only decoder, which means it's not interested in understanding the input structure. It just cares about how one outcome follows. One outcome is followed by a set of previous outcomes. So very aimless. But the funny thing is that it performs very well. And it really delivers very convincing narratives. I mean, narrative is not a simple storytelling. Narrative includes very specific social actors' interpretation and experience of within a certain story. So, as you said, it's pretty interactive. So if I use ChatGPT repeatedly, it will learn me, and it will increasingly provide me with more and more convincing narratives. I guess I'm afraid of that, in fact. So through that interaction, we generate new data, and it will learn it, and we will become close to each other, and so on. So at that point, then what is the real evidence or the scientific narratives? I mean, I don't know, honestly. So I mean, we have to act much early. I mean, so it's kind of in some sense, adversarial machine learning, I think. So there's a human feedback, and the ChatGPT learn it and fix a problem in terms of business model. But I think in terms of public good, we have to do that, and we scientists should collectively think about this problem. How can we build publicly very advantageous human feedback to this kind of generative AI? That's my best answer right now.
Thank you very much. And I think that already touches on a comment made by our Vice Chancellor, Professor Chuan, this morning, the criticism of garbage in, garbage out. Okay, so I know David have been working very diligently to identify ways to protect the reliability and validity of our data. But does big data, data science actually introduce new complexity into the thinking of validity and reliability of data? And what can behavioral and social scientists do to really protect the integrity of data and also the reliability of data use in computational social science? So are there like new things that we need to consider, like Derek?
Yeah, thanks. So earlier my remarks were quite general. So this question is quite technical, which is quite good, right? Then we can address the issues from different levels of analysis because we have different interests in the audience. I think the foundational measurement issues are there, right? So with 300 years of psychometrics, social indicators research and all, so we know what is reliability, which is consistency of scores, whether it's across time, across items, across raters, across measures, and so on. And we know what is validity, right? That is the accuracy of the inferences you draw from the test scores or the scores that you have. So what is reliable need not be valid, right? We can all be consistently wrong, right? So we can be very reliable. I keep asking you a question, you keep on giving me the same answer, but you're totally wrong. You are totally reliable, but you're invalid, right? But it's hard to talk about validity if there's no consistency. That's what social scientists believe, because we believe in replicability and generalizability, right? So these are concepts which half the audience will probably be very familiar with, so I won't go into detail. So I would argue that our computational technology people, I love them, I work with them for years and all, and they are my good friends, and they are humble enough to recognize that these concepts actually are quite alien to most of them. So we do not assume that they believe they know the similar things about reliability and validity that you in your graduate school have acquired. So the first challenge we have is to aware of our different paradigms, and not see them as clashes, but to understand the awareness. But as you work with the computational technologies people who are very humble to come to the social scientists and say, hey, we have lots of data, we know things are producing, but please help me to interpret, I haven't actually met a computational technologist in Singapore that is arrogant, that says, what does social science know? I think that is actually quite not true. In fact, I have to say that I have met social scientists who say, please come and talk to the computational scientists. They do know things that you don't, And I think the point I'm trying to say here is this. Number one, social scientists, the methodological people, you have very important concepts that you need to share, and you need to help out with our colleagues in computational technology who actually very much needs their data, their models to be validated, needs to have reliable measurements, because it is possible to produce all kinds of things. Most of you are in modeling, regression, capitalization of chance, structure equation modeling. How you give me a set of data, I can produce two completely theoretical different models and they still both fit perfectly. So which is right? So in model fitting, we also have the problem of abusing things and all. So we talk about pattern emergence, pattern recognition in computational stuff. The pattern, the model that you came up with before you go and tell the Prime Minister, please do this, this is what my data show, I think it's the moral act that we are doing, because if the Prime Minister believes in you and go ahead and do it, you are affecting people's lives, right? So I would argue that as scientists, you will want to make sure that before your so-called insights are translated into practical applications, you want to make sure it's reliable, valid, the inferences that you draw from the scores are actually accurate. And that's where your measurement people can help. But I will run out by saying that, don't be too arrogant, the measurement people. Actually, computational scientists tell us a lot of things that now you realize that you are not totally right as well, right? So our reliability, consistency, I don't think, I'm a psychometrician too, I don't think that is the only important thing. There are things that need not be reliable. I know this is going to be controversial. Right? When you think about it, there are things that happen only once in the history of mankind or humankind. How are you going to have consistency or replicability? But that event could be highly important. So it is not true that every important thing need to have consistency across time, across measures. You then have to interpret this data, what it means, and so on. So I would argue that we need to have the humility to come together and say, look, please understand reliability, cross-validation, this is how I can help you. At the same time, realize that when it comes to big data and dynamism of data, it is different from your typical static longitudinal analysis, that any one time, whether CY look at it today or I, David Chan, look at it tomorrow, is still the same data. In big data, that it would have changed, right? When CY look at it today and I look at it tomorrow, actually the data have changed because it is big dynamic data. And when that happens, what does it do to our concepts of consistency, validity? It doesn't mean it's not analyzable. It just means that you need to understand how things changes. When things go into changes, there are different ways of looking at things. A very quick example, I just heard you talk about basically density and vibrancy in urban planning. I happen to do some urban planning work in Singapore. I will very quickly say that social scientists will be able to tell us that density is not the most important thing, it is crowding, right? If I put 5 of us in one small little room and we know each other very well, we are quite happy, quite cozy. But if you put 5 of us together who are strangers or we're still enemies, 4 of us, we want to get out immediately. So density is actually not the psychological important thing that affects your behavior, it is about the crowding perception. Now, so most of us then get away with this social scientists think that density is bad, too crowded is bad, so I don't want to be in too crowded place, relax. Then urban planners will tell us that's not true. You need vibrancy. It is very boring to be in a place where there's nobody, right? So you need vibrancy. So that means that when you look at density on x-axis, Y in terms of your well-being and quality of life is actually not linear but curvilinear. Now, in a normal statistics, you'll just do a normal regression and so on. But now in the dynamic data, what can I do? I can actually model different ways of vibrancy and look at behavioral manifestation and indication. And that requires different ways of psychometrics and methods in terms of analyzing and interpreting those data. But I think I better stop there. The general point I want to make is that You have the measurement and social scientists to help our computational colleagues, but our computational colleagues' data are producing things that not only need your help, they are informing you in terms of your methodological and your theoretical insights.
Yeah, thank you. Thank you very much, David. I think your answer goes beyond methodological concerns. Now, I'm a social psychologist, and one phenomenon that we are very familiar with in social psychology is that if you hear the same message several times, multiple times, even though initially you know that this message is incorrect, you come to believe in the validity of that. So I think AI can generate relatively consistent messages, but whether or not it is correct is one limitation of generative GPT or other generative AI platform is that it has no power or is not set up to verify the validity of information by itself. Okay, so you tell what GPT is the, and GPT would just say, okay, this is the data. Okay, so it has no ability yet to independently verify the validity of information. So this actually creates a larger social problem. Now, let me share with you one example. When GPT was available in the market, I played with it. I asked GPT this question: who is the current dean of social science at Chinese University of Hong Kong? And his answer is, as of 2020, the dean of social science at the Chinese University of Hong Kong is Professor Fanny Zheng. Okay, I asked again, Fanny Zheng. I asked again, Fanny Zheng. I asked again, Fanny Zheng. Initially, I don't believe in the answer, but eventually, I think I have to accept it. Right. So I think that is the kind of problem that we need to deal with. Now, for me, I know who I am, but a lot of people who don't know too much about the lousy dean of social science Chinese U has, they may come to believe that Professor Fanny Zheng is the dean of social science of the Chinese U of Hong Kong, at least of 2020. Now, so I think this is actually some issues that we really need to think about. Okay, generative AI, data science, and its application is going to make information more accessible to us. But it will also create hallucination. It will also create all kinds of false beliefs. And I think as social scientists, we are also concerned, how can we protect our citizens against those misinformation and also the misinterpretation of the information? I can tell you that by now, the Dean of Social Science at Chinese U of Hong Kong is Fanny Zheng. Anybody?
So are you the dean?
I don't know. I'm confused.
Yeah, I find it very interesting that the ChatGPT seems to be only a kind of a front end and the back end is not so accessible, right? So the standards that we have in academic writing, where you always need to be able to trace the sources, is not there. So there's no way of independently verifying. The other danger maybe is that is always only sourcing information that's already out there. The analogy that I would make to urban planning, which is related to this comment about density. If we, for instance, take activity patterns in public space, whether they're travel movements in public transport or in a smaller scale, we're only analyzing maybe the revealed preferences of people that are already there. But what about the people that are not there, that are actually not using those space because it's not attractive to them, right? So it's maybe a wider problem that the size of the data set is also limiting, and the way we sort of approach and analyze the data set is actually sort of making us blind to understand wider opportunities that allow us to think more innovative about changing something about the solutions to be more inclusive in the longer term. I don't know if that's addressed your question, but it's an interpretation.
Yes, I think we have done our job as being the appetizer of a big meal. So now I think we are ready to open the floor to the participant, and you are the main course. Okay, so if you want to ask any questions or make a comments, please just raise your hand if you are in the audience, in the online audience. Sorry, please, in the auditorium here. And if you are joining us online, you can send your questions to our Q&A box. Okay. Anybody from the audience first? Okay.
Hi, thank you. I want to make a. I agree with Professor CY's comment on the Benny Zhang being the head of social science. I think in the machine learning world, you cannot come up with a good model without the active, close participation with the domain experts, right? Because the only way to make your model more accurate is by using domain expert to help with the supervised training, right? To quote a silly example, when we're training a chatbot, when somebody says Yao Jin Wang, right, we have to teach the model that is nothing to do with toast with butter and jam, right? It's actually the name of 3 locations together, right? Yeah, so that's why in my line of business, we often come across very diagnosis or illness with its 26 character of English Latin words, right? There's no way absolutely we can get it right. So we need the claim expert to really work with us, even doctors to work with us hands in hand to make sure our model is accurate. I think that the generative AI is far from perfect, but you need to make sure you expose it with quality data, right? And if you wrongly train it with not so very biased data, then you need to untrain it, right? So it is not just a traditional, it's a data science job. It cannot be, right? In the commercial world, you need to have the expert to work with you hand in hand. It's a collaborative model. It's not a research model. Otherwise, you won't get it. All right, thanks.
Thank you very much for sharing this very important point. I can share a story of you. Just a few months ago, I was invited to give a presentation at a conference on generative AI in Tsinghua, hosted by the Tsinghua University. I was not able to physically present because of my other commitment. So I provide a script, and they find somebody to collect my speech samples, ask the AI to do some deep learning, and then produce my presentation at the conference. So that is a presentation by my digital twin, basically. So I start to worry, okay, so am I going to lose my job? Because, well, it seems that I don't really need to be physically present in a conference. My digital twin can actually present the talk for me, and maybe later my digital twin can just deep learn my publications and then come up with the script by itself. So I think this is actually some kind of anxiety being circulated in our community. Are AI going to replace humans and take our jobs? Is this a realistic fear? I think what you mentioned just now confers some confidence. Although I cannot give the presentation, I can supervise my digital twins to give the presentation. Is that the case? Perhaps I think we can open the floor to the audience and see if, this is a realistic threat, or is actually or alternatively there is something only humans can do. All right. And then we can also think about what are the implications for higher education, if that is the case. Yes, certainly. Yeah.
Okay, well, this afternoon after lunch, there is a panel where our industry experts are going to talk about ChatGPT and related stuff, right? So So I think I look forward to that, because there'll be quite a lot of conversations on ChatGPT by people who actually have to deal with it right now, in terms of bottom lines and real people's lives. This panel, we are researchers, although most of us also work with governments and organizations, but they are really full-time people doing that. So I would urge all of you to stay back after lunch to listen about ChatGPT. If I may just want to address a little bit about that and tie it together with today's panel's point about computational social sciences, which of course goes beyond ChatGPT. I think whether it's ChatGPT or actually other generative AI or other advances in technology, we are going to get more and more of that. It has already created anxiety in everybody, right? When technology first came about, Industrial Revolution, we thought everybody's going to be jobless. That's not true. People adapt, and then people do different kinds of jobs. But it does affect the structure of society. The sociologists will be able to explain to us what does that do to inequality, to geographical areas and so on. So it's the same thing I think will happen. I think what the message for us as social scientists, where many of you are, and also computational people, is that in the past, if you don't like computational social sciences, I'm sorry, now you have to like it. You have to actually start working on it. Just like you don't like to deal with it, but as a professor, you have to deal with it now, because you don't know whether your student essays, your theses are, which part is ChatGPT and which part is theirs. Right? In fact, we had a quick discussion, in SMU when all this thing happened, because we were like, so what do we do now? Can I penalize my student, or should I not penalize my student? Because there's also implication, right? If you can't prove there's no trail, you can't prove the person used ChatGPT and you start making the allegation, that's not fair. It also has other implications about the grading and all. And then some of my colleagues say, don't worry, David, we can look at ChatGPT, and then if you produce inconsistent facts, the arguments are incoherent, then it's from the machine. I say, that's not true. That also can be from students or faculty members, right, who can be incoherent and so on. So it's really quite difficult to tell between the ChatGPT and a non-ChatGPT, a real person. I would say, however, unlearning is a bit different. In certain machines and algorithms, right, as the generation goes, the degree of unlearning is probably quite similar, depending on the development. Just like think about a machine of an iPhone being developed. At any stage of development, you have about a similar kind of degree of unlearning abilities. Human beings, however, in terms of adaptability, we have huge individual differences in the ability to learn and the ability to unlearn. So there you go, you have a quite different between the status quo between human beings' ability to learn and unlearn and relearn, between the machine depending on the generational times. One day they may be able to unlearn very fast, but today they are able to unlearn within a restricted range. Whereas human beings, we have an entire range. So there you go, you have some differences between machines and between humans. So that's a simple analogy to say that there are many differences that we've got to figure out. These differences may narrow, but as the differences narrow, humans will change as well, right? Which goes back to the point about online and cyber matters and all. One of the things that we should start studying more seriously is not just sentiments of online. That's very important. But what about the interface between the online world and the physical world? How does online world actually spill over to your thoughts and feelings in the real world, and how your real world affect the online world? Now with metaverse and virtual reality and immersive situations, the lines are blurred. I think that's very important, and we are not putting enough effort on that, right? If you look at the social scientists studying online and computational studies, they are still at the level of, are these emotion word, positive, negative, maybe is this sarcasm, is this positive and not? That's not enough, I think, right? I think we have to move way beyond that to talk about the interface between the worlds, because that's going to affect our well-being, our mental health. It's going to affect voting behaviors. It's going to affect every other thing. So social scientists, if you don't like CSS, please start liking it now.
All right. Can I just add shortly on your comments here? I agree with that. The models need this domain-specific quality data, and we can say it supervised learning. But if you allow me to be a very pessimistic, dark side sociologist, then I think there could be two problems. The one is when we train the AI, we give human feedback. And if there is very high quality human feedback, AI will learn very fast from that human feedback. So it doesn't need that human feedback anymore in the future. So I mean, the problem is this kind of supervised learning may not be that sustainable when the human feedback is pretty high quality. That's possible, and just one scenario. And the other thing is that I just kind of sense that some people, or these very AI-oriented people, start to believe that this is not AI anymore, but AGI, so yeah, artificial general intelligence, which means they believe that this ChatGPT really improved the scalability of AI to a totally different level. So learning at one domain can really jump to other domain and performs very well in other domains. And we don't know yet whether there is a really, so do we really jump to that AGI? We don't know yet, but I don't. That's possible. So we have to probably see that. So how much domain-specific knowledge or this kind of the human-based modeling ability is that really valid in the future? I think maybe not. I mean, some people believe that that's not really important anymore, I guess.
So thank you. I think my question is specifically addressing to Professor David Chen, or maybe also Dean Chu. So the question is, in kind of behavior study, people now use some rich data from, let's say, speech data, so they can do language modeling to measure, for example, the personality or certain kind of psychological traits. For example, people use this company executive speech data and then try to study this. So my specific question is, I heard that nowadays some companies actually train their executives how to talk so that they can sort of counter this textual analysis. So my question is, what is the limit of now this type of study? The limit in terms of how we learn the true, let's say, the personal traits of certain people, because now they're kind of aware that they are learned by machine, and then there's kind of the strategic training for those people that, they talk in a certain way, so that, for example, something when they disclose the company decisions, they probably want to disclose it in a more strategic way. So it's not just like a sentiment, like positive or negative. It's more complicated. Yeah, so that's my specific question. What is the limit of the machine learning in this kind of personal traits? Maybe another minor question is, what do you think is a better way to do this kind of research? I mean, it's very difficult to do the survey or interview to learn the true personal traits. But I mean, people are very interested in learning that. So in your opinion, what is a good way in the nowadays the whole world of the CSS? Thank you.
It's quite a complicated question, right, depending on which levels you look at it. Now, if you're looking at it from a honesty faking personnel selection viewpoint, right? Your point about if I know the algorithm or the textual analysis, the way you score, then whether you are the employees or whether you're the applicant for the job, or even to project certain strategic image, actually you basically can manipulate the data to produce a particular desired or projected personality or organizational image, which is actually not the true score. I think that can be a way to say if that is the question. But that actually exists in today's without computational as well, right? Because I can fake on your personality test. If you tell me how you score your big 5 personality tests, which some of you are very familiar with, I not only can fake and say, okay, if you ask me, do I worry a lot? I will of course say, no, I'm applying for your job. Why do I say I worry a lot, right? But then if I know that actually you have a life scale, actually that's how you score, you're not heading for the top scorer, I know you're measuring these 5 particular traits. If I know how you score, I will even be able to project a very good image that you will select me, because you're probably not just going to select the high score. You do that when you're selecting pastors, but then you don't select it for a banker, right? You actually will say certain profile and so on. So that already exists in today's world, that in any selection or assessment system, if the person being assessed know your algorithm or know your scoring method or know your intention is equivalent to what we learn in experiments as demand characteristics, that, oh, this is what the researcher wants, this is what I'll do in order to give you, in order to fake good or fake bad. So as a social scientist will be able to tell you that that is actually true regardless of the methodology. The question I think is important here is that with all this algorithm and textual analysis, actually the same caveats would apply. We therefore have to be a bit more careful that just because it is machine-based or machine learning or algorithm, it is actually not more sophisticated in any way. You know, if I know your algorithm, I can fake as well. So that's one implication of that, right? Don't be carried away by the sophistication of lots of numbers and machine that, oh, it's not fakeable. Number two, I would argue that it doesn't mean that you should stop using it. Just like we don't stop using personality tests. We begin to learn how to use personality tests better. We begin to know how to cross-validate. We begin to know how to make interviews that are more structured. You know, by the way, interviews, I said to say to employers and employees, when you don't structure your interviews, the validity evidence is very clear. The validity is zero, right? Zero, you know, when you don't structure your interview. It's only when the interviews are properly structured, we're properly trained, then the interview scores actually are not zero. There's some validity in predicting the actual performance subsequent later. So it is possible in a method like just interview to have different degrees of structure training to make it more or less valid. In the same way, I would argue that in any algorithm-based or any machine learning-based method in application, there will be ways to make it more or less valid, and the only is not to just hide the algorithm from people. In fact, I will be quite careful when algorithms are only known to the developer or an organization. It's just like, how then do I replicate? How do I know you're not bluffing me, right? If I do a consultant for Singapore's government and I refuse to reveal the statistical method I use or the way I compute my scale scores, I could be bluffing, right? How do we know, right? You're just believing in my integrity. And I would argue that as some practitioners, we must be able to be comfortable and learn to be able to reveal some of these things. Of course, the practical and business will make it difficult because I don't want to share my scoring and algorithm, right? If I share my everything with CY, CY can do the consulting, you know, that I will be out of their consulting job, you see. So those are the kinds of, CY say no, CY say I'm not that dean, you know. So I think that those are the kinds of things that we have to and we need role models. We need people who are comfortable to quickly do some of these things. And when you start sharing your things, you know, when Google share, Microsoft will share, and other people will share, you see, because there are competitive challenges for people who share and people who don't share.
Yeah, I just want to add another aspect to David's very clear answer to your question. One of my former colleagues at Nanyang Technological University, Professor Chu Nin, actually, he published a study about 10 years ago. So he compared the same user who used different social media, like Facebook, Twitter, and Weibo in China, and see how their self-expression tell us their digital personality. And he finds out that the personality actually differ very drastically when the same person uses one media versus the other. So the same person can appear to be very self-affirmative, very assertive when they are using Western media. Okay, and they became more collectivistic, more caring, more concerned about others' well-being when they present themselves in a Chinese media. It's the same person. So that tells you something very interesting. So our social media is now very accessible to people. It's more accessible than even like face-to-face interaction when you want to like gain information about a person. And so people are, particularly younger people, are now paying a lot of money and also spending a lot of time to manage their digital self-concept. Okay, and self-concept should not be like singular, it's self-concepts. Okay, so multiple self-concepts. And it is a very serious issue. Okay, so if you challenge somebody's digital self-concept, they may get really upset. So you give them unfavorable weighting, or dislike, okay, they get very upset. And they try very hard in order to make sure that they get a lot of likes for their post. Now, that actually creates some very interesting problems and research questions for social and behavioral scientists. How people manage their digital self-concepts across different platforms. And how do their digital self-concept actually affect their subjective well-being and their interpersonal relations. That become another major issues that we need to handle. So discerning the true personality in social media, this may not be easy, given that people are doing a lot of self-management or impression management on the social media. So, but then, you would know, from how deliberately people manage their self-concept online to see what they really care about. Do they care about social approval more than care about, say, for example, like consistently portraying a consistent self-image of in a certain direction in the media? So that could be like another indication of what they really care about, which may be important for personnel selection. So that is, I cannot really do the consultant's work that David is doing, because he is really grow in the area. Over the years, I've been learning a lot from his posts, and they are very consistent. They're consistently professional. That's what I have to say.
I thought he was going to say consistently wrong. But just a very quick comment. I agree with totally what he said. I'll just add that it was my earlier point. The online world is not virtual in the sense that it's not real. It's real. The time that your kids spend on online world is more than the time the kids spend in the working world, not online, for most people. So it is real. And when you have feelings and thoughts and behaviors, don't disturb me. I'm not going to eat the porridge now because I'm playing a game. You have just told your parents off, right? So this is a physical world that you did because of the online world engagement, which is my point that we tend, social scientists tend to say online is fake. What about the real personality, the real behavior? No, right? There are two worlds that we are living. Now there's a merged world, and now we are always talking about how one world affects the other. I think that's the kinds of things that we need to work on, and that's why faking what is online, and when it's different from the real world, it doesn't mean the online is faking the real. Yeah, it means that online and real world different. In real world, you behave differently. That's all it means. It doesn't mean that the online world is fake. The real world is the truth. Right? In fact, I would argue that the online world, if I don't like a political party, I actually express it because my name is not there. But in the real world, I pretend to like the political party because I need you for whatever reason. Right? So in that sense, in that example, the real me is in the online world, not in the real world, right? Because in the real world, I'm not going to express my true feelings about this political party. And if you're the political party, when I go and vote, and because the voting is secret in most countries, you will actually vote not for the party. So it affected the real world. So if you are a policymaker, you believe that the real world behavior that by David Chan is the real thing and not his online, then you are wrong. And that's why you need to study the online world, even though you're interested in the physical world, in terms of the physical voting and so on, right?
Thank you for the panelists for the very interesting discussion. I have two questions. The first one is about the research paradigm in social science. Usually in social science, it's kind of when we do some research, it's theory-driven. We have some theory, then we wanted to have some kind of a hypothesis. We kind of seek data to try to support not support our hypothesis. So I wonder how the kind of the computation social science impact the paradigm, because there is also a kind of a minor kind of a stream of research they emphasize data-driven research. So instead of theory-driven, they are data-driven. So I wonder how the large big data availability will impact the paradigm of the doing research in social science. My second question is about the research ethics, because I'm kind of serving as a gatekeeper for the behavior and social science research for our university, and approve or disapprove the research ethical review. So far we haven't received lots of such kind of studies related to big data. But I find from other, the student defense, from other studies, I kind of increasingly realize there will be some challenges in the future about the research, the ARB or the research ethics in terms of using online data. So maybe the panelists can share some thoughts about the future research ethics issues. Thank you.
Thank you very much for the questions. I think what I would like to do is to really invite all participants here to try to reflect on these two very important questions and share their thoughts and insights. So perhaps before the panelists answer the questions, may I see if members in the audience would like to share their thoughts on this one as well? I think these are very important questions. Tony.
I will try to answer this question because I wear two hats coming into this forum. One hat is being the director of the Computational Social Science Lab at CUHK. The other hat is someone with limited, bounded human intelligence. So partly addressing Yuying's earlier question, and partly my question to the panelists as well. I think computational social science is a powerful, powerful approach to understanding social problems and answering fundamental social science questions. It's powerful because it has the ability to enrich and totally turn upside down or disrupt the current standards of data, analytics, and evidence, how we define, construe as so-called relevant and significant evidence. All those things can change our paradigms of doing social science and policy research. So my understanding of the panelists' discussion so far is I'm totally on the same page with the panelists, but my limited intelligence puts me to make two projections. I want to see if our audience here, as well as our panelists, have better thoughts than my limited model. Because of my understanding of computational social science being an approach to answering questions, rather than a theoretical approach or a discipline. So I project that there's no way in the near future to have something called the discipline of computational social science. Would you say the same, being practitioner, good practitioner in computational social science? Second projection. Even though it cannot be a discipline in the near future because of the constraint of knowledge, its knowledge structure, but it has internal dynamics to drive it to form a community of scholars in doing computational social science. That is due to my understanding, as David said very well upfront, the dynamic of people coming together, producing transdisciplinary insights and so on. Those things do not produce disciplines of knowledge, but can enrich the power and demonstrate the power of such a computational approach. That is my limited projection. Would you, as practitioner in the forefront of computational social science, and our audience who may be ready to leap into it, and our industry partners who have been consumer of computational social science products, think these two are indeed possible. So it's partly my projection. My projection is an answer to Yuying's question, but also basis of my two questions to the panelists. Thank you.
Yeah, thank you very much, Tony. I think we have already Okay, I see a hand raised here. So, Professor Xu Zhang.
Sorry, I raised my hands because I understand there's many people I would like to ask questions, and I think my question is quite. I don't have any solution for Yuyin's question because perhaps I add one more question to his first questions because I think my question is highly related to her first questions. My question is, does computational social science have to be big data driven? Because when we talk about computational social science and panelists here and many audience here think about big data, right? But if we look at the traditional, my background first, okay, I'm a theory-driven researcher with very limited knowledge on computational technology, okay? But I'm moving towards a study on digital governance. And then because if you look at traditional social science research, and many social scientists, they have a long tradition of using data and modeling in the research already, right? But so my question is, if you even look at the computational technology, I think there is two fundamental different approaches. My understanding may be very naive. One approach is that we have very small data inputs, and then the output is very big. Say, for example, the simulation, right? And then the second approach is that we have very big data inputs, and then the output is very small. Say, for example, the ChatGPT, right? You have to rely on big data, and then the output is very small. Say, like individual inquiry, answer to your individual inquiry, right? So, well, I think this observation, perhaps very naive, but is very fundamentally related to the question I would like to ask, whether computational social science has to be big data driven, right?
Thank you. Okay, so I think we just start the discussion, right? So I'd like to have the discussion go on. So instead of trying to bring closure to the discussion, so I still want to see, okay, whether or not you have other thoughts or ideas or comments that you would contribute to the discussion. If not, maybe I ask Johan to give some comments or some responses to the questions.
Okay, so I probably cannot answer all of the questions or comments here, but maybe I just answer a part of them, and the other panelists will answer other questions. Well, I have a natural science background in college. I majored in mathematics, but when the term big data was in a huge fashion about 10 years ago, I was not really interested in it because it doesn't have any theory. I mean, even natural scientists or mathematicians, they work with equation. That is a model, kind of a natural science theory. So once you don't have that kind of a model, you are not really interested in it. So right now I'm social scientist, and I totally agree with you that data science cannot be reduced to or computational social science is not reducible to data mining. It has theory anyway. Otherwise, we are not interested in it. So I think that's a basic common ground on that. And when I just proposed that narrative mining, what I actually aim for is to build or develop computational social science, which is much more effective for smaller data. I mean, even with some interview data, relatively small, I kind of sense that if we really extract the narratives, and there is a certain social event, and if you interview several different people of different social identities, and then you can really find something very, very rich. I mean, it doesn't have to be hypothesis testing. Sometimes by discovering those narratives, it's a kind of exploring new hypotheses for your future research. So it's much more interpretative. There is much more interpretative values I mean, so people tend to assume that computational social science is good at prediction, but it's pretty poor at interpretation. But I want to switch that kind of vision, and it could be more helpful for those small data-driven or much qualitative or theory-driven research. And I can probably partly answer to that ethical issue or IRB, because I'm an IRB review member in my university. So it's a typical pattern is the easiest one is social survey. It doesn't have that big problem. The next ethical problem happens for a laboratory experiment. And the more serious problem is about field research. And computational social science sometimes involved field experiment. So it has very big ethical issues. And even though you just scroll publicly available social media data, you should be very, very careful, because you may reveal certain privacy, which is pretty unexpected, even though you just use the publicly available data. So the point is that computational social science is a set of all possible complex ethical problems. And we don't have an answer yet. What we can say right now is, as I know, so it shouldn't be rule-based review. It's much more principle-based review, so a little bit flexible. Otherwise, if we would just apply strict rules to a very computational social science proposal, then it's very unlikely to pass the review process. So that's at least the situation in my university. But there are few proposals using computational social science by far. But I'm expecting more and more computational social science proposals coming to this IRB review board.
Yeah, from my point of view, I can also answer the question maybe with specific examples that in urban research, urban design related sort of applied research, it is always theory driven, and we don't see it actually as an opposite sort of option, but we always start with certain assumptions that we then try to test and probe, right? Especially, for instance, when we think about urban environments, which connects to theories from landscape and environment behavior, for instance, project refuge theory or Gibson theory of affordances, how people respond to certain qualities of their environment. Do we instinctively feel safe in certain kind of enclosed or more open areas when we can survey, or how do we respond to other people's presence or activities near us in urban spaces? And a lot of the literature on that is all based on assumptions, right? And the data-driven approach allows us to really start to test with very specific examples whether these assumptions are true or under which conditions or in which locations. And it allows to see much more regional variations, cultural variations, the specific conditions which makes these phenomenon different. So in a way, it's enriching the theoretical understanding as well. For instance, when it's about environment psychology or environment behavior. The other approach that we see, I see in the papers that I read, is that the data-driven approach, sometimes it sort of points out to completely new theories, right? Or actually completely disproves existing theories. For instance, how people's sort of work-live preferences relate to the distance to CBD or something, where there's a lot of research now, especially around COVID times, where people have completely different preferences than what economists or geographers would assume. So the data-driven approach sort of allows for immersion of completely a new understanding of much more complex behavior of people decision-making in urban environments. The ethics part is very interesting because my own research is about video tracking of people activities in public space, which is probably quite controversial if you imagine that we can use CCTV footage to understand whether people are socializing or individual, or whether they are avoiding others or feel attracted to others. We know that some organizations are using this. Apparently, the London Underground is automatically tracking for terrorist activities and things like that. But our research actually sort of, in a way, paving the way for a kind of an automated monitoring system of people's behavior with, the good intention of trying to make housing estates more friendly and user-oriented. But at the same time, this opens up huge possibilities for misuse, or it touches on the surveillance anxiety that many people rightfully may have about these kind of techniques. So we've gone through a full ethics review, and we have to be very detailed about how we use the footage, where we store it. Do we make it blurred on purpose so we don't detect features that can identify people? And we only try to capture statistics of movement patterns. And that is, I think, becoming a more and more important issue, ongoing, and I wish there would be more transparency and accountability for those sort of commercial systems that we're also walking around with, that are monitoring and potentially listening into everything that we say and do.
Okay, I'll be concise. A bit hard enough for 5 questions, but I will just not cover what my panelists have said, of which most, if not all, I agree. I think we need to make clear there are certain distinctions that are related but distinct. Theory-driven and data-driven is not the same as hypothesis testing and exploratory research. It's not the same as nomothetic versus idiographic research. It's not the same as quantitative versus qualitative research. Right? So we won't have time to go into this. We can do a workshop next time if you're free. A free workshop, no charge. Note that we can kind of understand, once you understand these distinctions, then you realize that these distinctions sometimes are just heuristic that we use to describe any research. Any good research probably need everything, right? It is not true that the social scientists are all hypothesis testing. What in certain disciplines, in ethnography, for example, anthropology, there's a lot of idiographic approaches using of qualitative data and not just quantitative. Even I, being an empirical guy, I use qualitative data now and then as well, right? Just that I try to give a structure to it, maybe in a way quite different from, say, an anthropologist or an ethnographer. So I think once you make those distinctions clear, then I think it becomes quite clear that in computational social sciences, it is true that if you are a computations STEM kind of a technical person that have no exposure whatsoever and background and no colleagues to talk to in social sciences, then we have a problem. Why? Because you are trying to address society, groups, and individual thoughts, feelings, and behaviors, and don't reinvent the wheel because there are 300 years of empirically validated research on those. That's why you need the help of these social behavioral scientists to come and tell you about how people behave, how people vote, how people, what is self-esteem, what is self-concepts, and so on. So you need those theories in that sense. But I think it is false to say that the social scientists are all theory-based, theory-driven, then the computational people are not, because they're dealing with those kinds of data, right? You can apply those theories to whatever data, which goes to the second point, that is it small data in, big inferences out, or big data in, small inferences out, or small, or big, big. I think that distinction is completely independent of discipline, right? In social sciences, in psychology, I can give you tons of examples of small, big data in and out, and then I can factorially cross for you and describe studies to you in a meta-analysis. So it can be done, right? On IRB, I set up the IRB in SMU many years ago. I would argue that what will happen is that your IRB chair person and the members must learn to seek expertise in these few years outside your own people. Because it is not possible to just put all the computational scientists on IRB, they will reject you, they are busy doing their research. So what you need to do is that when you read something so strange, please don't just accept or reject. Right? Pick up the phone, send an email to a trusted colleague, and ask the person. So very often I will have IRB chairperson or IRB members who informally will ask me, David, can I chat with you, on this particular proposal without violating confidentiality? The guy was doing that, is that what you guys do? That kinds of things should happen, right? At least in the next few years, as you make important decisions, because you can either hurt a person or you can very badly, actually wrongly, have reputational risk of your university by protecting faculty in the right or wrong way, right? Because IRB is not just to protect human subjects, it protects the faculty as well, right? Because the institution now stand behind you if you follow my protocol. So I think that is very important. So I'll just round off. I know I shouldn't answer all questions, but I really cannot not address the issue about being this. Is it going to be a discipline? Well, if I decide now that all the traditional disciplines are discipline, then by definition, it's already not a discipline, right? And that's how cognitive science happened in Stanford. When cognitive science happened, it was a linguistic, artificial intelligence, computer, people psychology, neuropsychology, all came together. They became cognitive science. Is cognitive science a discipline now? Doesn't matter to me, right? You just do good cognitive science. So I would argue that so long as we do good computational sciences, social sciences, we continue to have your lab, continue to have majors in undergrad and grad, continue to make sure you have such forums, then you solve people's problem. That's what science should be. I don't really care is CSS a discipline or not. I care if people don't care about CSS. Right?
Thank you very much, everybody. There's a saying, good discussion never ends, but in the interest of time, we have to end it here. Although we can continue the discussion over lunch. We have a complimentary network lunch, and we can more freely explore these issues. So by way of summarizing, I think today we have some fascinating discussion on three, I think, interrelated aspects of computational social science. One is new phenomena that deserve attention from social science because of the rapid digital transformation of our society. So those are problems, phenomena that quite for answers, okay, from social science. I think that is one level. The second level is in response to all this empirical and theoretical challenges created by digital transformation. What can computational social science contribute to the solution of these problems? And what I would want to say is that we don't want to claim that computational social science, is the only solution to this set of issues. What we know is that, every discipline, every approach, every perspective helps. And I think computational social science perhaps can add a very valuable perspective and set of methods to the solution of this problem. So don't worry, we care about computational social science. And the third layer is what are the applications of computational social science in relation to the problems that we are solving. And that will really require transdisciplinary collaboration and as well as insights. And that, not accidentally, will be the theme of the afternoon session. So how do we actually bring practitioners, policymakers, innovators, and research scientists together to leverage on computational social science to create better models, better ideas, better products, better services, and for a better world. So I think that would be the challenge for the next panelists. So I consider myself fortunate to be the moderator of a less challenging panel. The next panel will be even more challenging and also more exciting. And so I look forward to seeing you again in the afternoon after the complimentary network lunch. So Angela, back to you. Before I do that, I pass the floor to Angela. May we thank our panelists for leading this discussion.
Thank you all the panelists for the very interesting discussion.